Have you ever wondered why each person's fingerprints are unique? Why no two people, not even identical twins, share the same fingerprints? This enigma is one of the many reasons why the study of fingerprints, or dactyloscopy, is so fascinating. Fingerprints, those distinctive patterns of ridges and valleys on our fingertips, are unique to each individual. This uniqueness has made fingerprints a crucial tool in personal identification, used in forensics and security for centuries. The science of fingerprints has its roots in ancient Babylon, where fingerprints on clay tablets were used for business transactions. Fast forward to the late 19th century, and we find the modern usage of fingerprints in criminal identification, thanks to Sir Francis Galton, a British scientist and cousin of Charles Darwin. So, it's clear that fingerprints play a crucial role in our lives. But what makes them unique? And why do we even have them? Understanding fingerprints requires a quick dive into embryology, the study of embryos and their development. Let's start from the beginning, from when you were just a tiny fetus in your mother's womb. This is where your fingerprints, or friction-ridged skin, as scientists call it, began to form. Around the 10th week of pregnancy, the skin on the tips of your fingers starts to grow faster than the rest of your hand. This rapid growth causes the skin to buckle and fold, creating the unique ridges and valleys that make up your fingerprints. But here's where it gets interesting. The way your skin folds is influenced by a multitude of factors that are completely random and unique to you. For example, the pressure within your mother's womb, the rate of blood flow to your fingers, and even your position in the womb can all contribute to the formation of your fingerprints. Because these factors are so varied and unpredictable, the odds of two people having identical fingerprints are virtually zero. In fact, even identical twins who share the same genetic code have different fingerprints. That's because although they share the same DNA, the conditions in the womb are never exactly the same for both fetuses. This randomness is what gives your fingerprints their unique pattern. But it's not just the pattern that's unique. Even the number and type of sweat pores on your fingers are individual to you. These sweat pores are located along the ridges of your fingerprints, and they secrete sweat which can leave behind your unique fingerprint pattern on the surfaces you touch. So, that's how our unique fingerprints form. But what about their purpose? Why do we have these intricate patterns on our fingers? Let's delve deeper into that in the next scene. Contrary to popular belief, fingerprints aren't just for identification. They serve a more fundamental purpose related to our sense of touch. Let's take a closer look at the ridges in our fingerprints. You may not have thought much about them, but these ridges actually play a crucial role in how we perceive and interact with our environment. In essence, they enhance our ability to sense textures. Imagine running your fingers over a piece of silk, or a rough stone. It's these ridges that allow us to distinguish between the two, providing us with a rich tapestry of tactile information about the world around us. But that's not all. These ridges also help us to grip and hold objects. Have you ever tried picking up a wet glass? It's a lot harder when your hands are wet too, isn't it? This is because water reduces friction between your skin and the glass. But thanks to the ridges in our fingerprints, we can still maintain a decent grip on the glass. The ridges increase the surface area of our fingertips in contact with the object, enhancing friction and making it easier for us to hold on to things. Now let's delve a little deeper into the world of fingerprints and talk about sweat pores. Yes, you heard that right. Our fingerprints are dotted with numerous sweat pores. Each person's fingerprints have a unique number and type of these pores. These sweat pores in our fingerprints secrete sweat, which further contributes to increasing friction and improving our grip. So our fingerprints are not just mere patterns on our fingertips. They are intricate designs of nature, serving a dual purpose, enhancing our sense of touch and improving our ability to grip objects. They are our personal sensory and gripping tools, helping us interact with and navigate through the world. So, our unique fingerprints not only identify us but also enhance our ability to interact with the world around us. But how does this uniqueness contribute to our sensitivity to touch? Our fingerprints have a direct impact on our sensitivity to touch, and it all comes down to the number and type of sweat pores on our fingers. Let's dive in. Each of our fingerprints is a complex network of sweat pores. These aren't just for perspiration, they also act as tiny amplifiers for touch. When we touch something, the ridges in our fingerprints trap tiny pockets of air. These air pockets create pressure on our sweat pores, which then transmit sensory information about the texture and temperature of the object to our brains. Now imagine you're running your fingers along the edge of a book or touching a hot cup of coffee. Your brain is receiving a flood of information from millions of sweat pores. Each pore is like a mini sensory organ, sending signals about the roughness or smoothness, coldness or warmth of the object. But there's a twist. Just as our fingerprints are unique, so too is our touch sensitivity. The number and type of sweat pores in our fingerprints vary from person to person. Some of us have a higher density of sweat pores, which can make us more sensitive to touch. Others might have fewer sweat pores but of a specific type that makes them more sensitive to temperature changes. So your best friend might be able to pick up a hot dish without flinching, while you need oven mitts. Or you might find the texture of a woolen sweater unbearable, while your sibling thinks it's just cozy. These differences can all be traced back to the uniqueness of our fingerprints. The variability in our fingerprints, therefore, is not just a matter of identity. It also shapes our tactile experiences, our interactions with the world around us. And there you have it, the science behind fingerprints and touch sensitivity. Fascinating, isn't it? Our unique fingerprints not only identify us but also shape our tactile experiences.